Okay, we're going to talk about mass percent because that's pretty confusing to people. And we'll do it a problem that converts mass percent to volume percent. We have three definitions of mass percent. The one we use exclusively in this class is mass percent is equal to the mass of the solute divided by the mass of the solution. This is my abbreviation for mass of solution. Solution is SOL''N. Percent volume is used once in a while. You need to know it. It's going to show up in some problems every once in a while. It's the volume of solute divided by the volume of solution. Again, it's not used often. And the third one is mass per volume percent. And that's mass of solute divided by the volume of solution. And it's not used often, and it shouldn't be used because you have to specify units. With the mass percent, it's always the same units as the mass of the solute and the mass of the solvent. It can be pounds, kilograms, grams, micrograms, whatever you use. Same with volume. It has to be the same. And I forgot something here. You should all know. I always do. It's times 100%. Times 100%. Times 100%. That puts it in percentage units. Okay, so those are definitions, and once again we use this equation: the mass total equal the mass of the solute plus the mass of the solvent. That's very useful. You have to remember that. All right, so let's do a problem. Let's take the one they do in the book. We're going to take the concentrated HCl is 37.0% by weight percent. The density is equal to 1.19 grams per milliliter. So I want to calculate the molarity and the molality. So I'm after the molarity, capital M, which that's not a very good one, capital M, and the molality, small m. The molarity is real easy. I'll do it over here to the side. The molarity is I just start with my definition, 37.0 grams of HCl per 100 grams of solution. And very carefully with my units here, at 1.19 grams of NaCl per milliliter of solution. That's the density of the thing, times 1,000 milliliters per liter times the molar mass of it. 1 mole HCl per 36.46 grams of HCl. And if I look at my units, got to be very careful with the units. I messed up. This should be grams of solution here per milliliter solution. So you got to be careful with that. And that gives me 12.07 moles of HCl per liter of solution. My milliliters cancel here, and I get moles per liter. Okay, easy, right? Now we'll do the molality. I could convert molality directly as I did in the previous video, or I could use a different thing. Let me move this up a little bit. So now I want to do the molality part, and I'll do it a slightly different way. I'm going to pick 100 grams total. I can pick whatever amount I want when I do these problems. 100 grams total is the mass that I pick. So the mass total has to equal the mass of HCl plus the mass, the solvent on there. That is always true, okay? And so I need to figure out what this is. So the mass total, and the reason I need to do that is I need the mass of solvent, okay? The mass of solvent I need. So if I have 100 grams total, by my definition of percentage, I then therefore have 37.0 grams of HCl. Okay, remember the percent was 37 grams of HCl per 100 grams of solution. Be very careful with this. Units plus the mass of the solvent. And so the mass of the solvent is equal to, and I did this already, 63 grams of solvent. Now I know the grams of that. If I want to get molality, I need to get the moles. Okay, and I'll have moles per kilogram. Okay, so the moles per kilogram, the moles, it was 37 grams of NaCl, because I assumed 100 grams, times 36.458 grams of HCl, HCl per mole of HCl. It gives me the moles of HCl, which is 1.015 moles of HCl. And so I have the moles and I have the kilograms. So the molality is 1.015 moles of HCl per 0.063 kilograms of solvent, which is equal to 16.11 moles of HCl per kilogram of solvent for the molality. Okay, there you go.